Okay, so transforming trig reciprocals. Same idea as what we did just before when we were exploring them, but we have a little more information now, right? We're a little better at it. So first of all, we want to get this into that form of our f at x is equal to a, the function k, x minus d, that's a d plus c, right? Well, that means we want to factor something out because we want our x value to have a coefficient of 1. And in this case, we have a coefficient of 0.5. So we're going to factor out common factor 0.5. Okay, so in other words, we're going to get 0.5, which will leave us with x. And when pi is divided by 0.5?
It's just pi over 0.5.
Okay, but how can we divide that? Think of it like 1 divided by 0.5. Do you know what that value is?
0.5.
Not quite. Try it on a calculator. If we were to multiply this fraction by 2, we get 2 over 1, which is...
Wait, which one? 1 over 0.5?
Yeah.
2.
2, exactly. So this now becomes 2 pi.
Okay.
Okay, so we have a much larger shift to it. And then we could also add something to the end if we want to see what a vertical transformation and horizontal vertical stretch looks like. But anyways, we have our cosecant. So instead of actually going from the sine function, because we know what we could do from here is go, okay, let me rewrite this question, do it in a different color. Let's rewrite it as a sine function because that's the reciprocal, and go 0.5 x plus 2 pi. Draw that out, and then we could draw our cosecant from there. But we're actually going to try from an original cosecant. Okay, so I'll take an actual, we're going to do radians right now. So let's scroll down. Okay, so let's actually try our original cosecants. Let's see if you remember them. Do you know where the asymptotes are for the cosecant function? There's one going to be what?
0.
Yeah. Where will another one be?
180.
180 or pi, right?
And then 2 pi.
Great. And then what about in the reverse?
Same thing.
Same thing,
Negative.
just a negative version. It's great. Okay, no, those aren't perfect. Okay, and then in between there, what are going to be our max and our min? For instance, going to the right of 0. So to the right of 0, what? 1 is my what?
Max.
It's my max, so this thing's going downwards?
Oh no, min.
Min, that's right. And then we know we have points along here. It's roughly something like this, right? Okay, and then from down here, that's a max at -1, right? And then the whole period takes 2 pi to repeat because our next one starts again over here. Great. Okay, we'll just start those. We'll quickly draw them in. Now talk to me about that k. What's that k going to do to the period?
Compress. No, stretch it.
Yes. Okay, it's going to stretch it. What's going to happen to the period? Instead of being at 2 pi, what do we do with that value of 2 pi to figure out the new version?
It goes by half, right?
So is it going to happen more often or less often?
More often.
What happened in the last version when it was 2?
More often.
It happened more often. This is
Less.
less often. That's right. So in other words, we'll do our new asymptotes. They're think of it as if they're going to double. So before we had 2 pi as a period, well, we can divide that value by our 0.5. Do you know what that's going to give us? No? Okay. So instead of being at 2 pi, our new period is 0 divided by 0.5 is going to be 4 pi. Okay? So even on this graph, I haven't done a very good job because we don't even get up to 4 pi on this graph, right? But what we'll do is we'll do one major one. We won't get a full period in. Okay? Actually, we'll get a whole period from left to right. Okay? So what we'll do is we'll draw a new one just with this transformation here. Before we even shift things to pi, we're just going to do that horizontal stretch of what's going to happen. So we'll do it in blue. So in other words, our new asymptotes, and you know what I'll do? I'll get rid of our old ones so that makes a little more sense to us. Okay, these old ones here. Our new asymptotes are going to occur half as often. So you notice how what I did is I got rid of the middle two, right? And we'll put them in blue. But our new asymptotes, we still have one at 0 to start, but our first asymptote happens at 2 pi. It's half as often, right? Before it was at pi, now it's at 2 pi. And same going the other way, okay? Which then means this thing is being stretched immensely. We still have the same max, or sorry, in this case, minimum. It's going to be at 1. And what's halfway between those asymptotes?
1.5. Oh, pi.
At pi, right? So it's going to happen there. So essentially, it's going to become a little more gradual come down. And we could plot those points. We can put them in. That wasn't the nicest looking U. But that's the idea. It happens. It takes twice as long for that event to happen. And same with on the other version. Okay, it comes up, around, and down. Okay, so if you notice, this period actually takes from negative 2 pi to 2 pi. That's how long it takes, which is essentially, that's the idea of a 4 pi in terms of the period. So that's how long it took. We had a down version and an up version. But from there, we're not done. The blue guy is technically only a graph of y equals cosecant 0.5x. That's only that. We haven't shifted this. So we'll shift this now. What color should we use? Green would be nice. 2 pi. Well, 2 pi moves everything what?
To left.
To left how much?
360.
Yeah, 360. So what does that happen to our asymptotes? They go to the next one. We really don't have to draw them again, right? Because the 2 pi shift is just going to move our asymptotes over. So we have the same asymptotes, and we'll put them in green, even though we can tell. We'll put them in green so we have an idea. So our new asymptotes are at the same spots, but what's happened is the graph itself has shifted 360. So this guy is now 360 to the left, or 2 pi to the left, so he's over here. Okay, still happening just as often, but now he's up here, and then the one that would have been down here in blue, it's come over here. So the green one is our final movement. Okay, that's our shift from our cosecant function. Does that make sense? That's our green one is our final. That's what this is here. Our cosecant shift of 2 and a stretch. So the period still takes 4 pi, right? The period still goes from here because we go up, and then we go down, and then the next one would be up at this point. So it still took 4 pi the period, but what happened is everything shifted to the left. Okay? Does that idea make sense?
Yeah.
Yeah. So there's your entire page.